Today we're going to talk about which clock is running faster. Okay, let's assume we have a rocket in a very deep space. Rocket. In the deep space. That means the rocket is far away from anything that has a mass. According to Newton's law of gravitational force, F equal to G m over r squared. So if r goes to infinity, F goes to 0. So if the rocket is very, very far away from anything, then there's no gravitational force from other object exerting influence on the rocket. So the rocket is free. Now let's assume the rocket, in fact, is moving with an acceleration a in that deep space. And we have an observer inside the deep space, inside the rocket. And within that rocket, we have two clocks. Clock A and clock B. So let's say A is in the front and the B is at the end of the rocket ship. So we want to measure the clock speed. How do you measure a clock speed? Normally, we assume that at each tick of the clock, tick, 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 at each tick of clock, A, we assume it emits a photon. So let's draw a big clock A here. And at each point, for example, at the beginning of 1 second, this clock emits a photon. This is photon 1. Photons 1 at the beginning of each tick. At beginning of another tick, which is, let's say, 1 second later, the clock emits a second of photons. So you keep doing this tick, emitting one photon, tick, emitting another photon, tick, emitting another photon, tick, emitting another photons. And the gap between ticks is 1 second. This is how we measure clock A. Then let's look at the clock B. This is clock B. So when clock B receives the first photon emitted by A, then we cut. This is the beginning of the tick. So when first photons is emitted by clock A and then it received by clock B, that's the beginning of the tick, then when does clock B receive the second photon emitted by clock A? That will determine the gap, okay, between the ticks. So that would be the T2. We want to find out what T2 is and how does that compare with T1. T1 is at 1 second apart. So in order to find that out, let's go back to the deep space within that rocket. And if this rocket emits first photon 1, and at that time the rocket speed is v01. Then later on, the rocket is moving forward. So let's rocket is moving forward. So rocket is moving forward. This is a clock B. And this is clock A. This is where when the first photon was emitted, this is where the photon was emitted. Then the photon going down this way, and it's going to hit receiver B, clock B. So the distance between this would be L1. Okay, that's the distance. L1. And this is the clock B. Okay, L1. By the time clock B receive photon 1, the rocket speed is V1. This should be V1. This should be V1. Okay. Then now let's look at the second photon. When the clock from within the rocket emit the second photon, say it start to emit the second photon here. The clock B is still here. At that time, we can call this speed of photon for a rocket is V02. And later on, the rocket is moving upwards. And clock B is here. And clock A is here. This is where when the second photon was emitted, this is where when the second photon was received by clock B. And that distance here is L2. And that speed when clock B received the second photon is V2. Okay, now if we look at this, we know that V2 should be bigger than V1 because the rocket is keep accelerating, and V1, V2 means B receiving photons. Then we also know V02 should equal V01. This is A emitting photons. By looking at this, you would immediately know that L2 is smaller than L1. Why? Because clock B is travel faster at a later time when it receives photon 2. So you only take photon 2 less distance before it hit clock B. It also means it takes less time for photon 2 to travel from clock A to clock B. That means if I go back to clock B, instead of receiving the photon 2 here, instead it should receive photon 2 here. And the T2 is a fraction of the original T1. That means when clock A emits 2 photons 1 second apart, clock B receives those 2 photons at a gap smaller than 1 second. Means you receive the 2 photons at a fraction of the 1 second. What does that mean? That means clock A is running faster. And clock B is running slower. That means when clock A ticking through 1 second, another second, 1 hour, another hour, clock B has not taken through all the seconds or hours, is falling behind. When clock A is, for example, 12 hours, and clock B may be less than 12 hours because its tick is slower every time. Every second is slower than clock A. Now if I look back, what does this mean? That means in the rocket ship, in the deep space, when the rocket is accelerating, the clock inside the rocket ship, if they are in different position, they have different running rate. Some clocks are running faster, some clocks are running slower. Each clock is different. And the clock in the head of the rocket ship is running faster, and the clock at the back of the rocket ship is running slower. All this is caused by the acceleration of the rocket